Hello everyone, welcome back to the fast track series of UGC NET Electronic Science. So in this video we are going to learn about class B power amplifier. Okay, the important points which you have to remember for class B power amplifier. If you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Okay, so class B power amplifier. So the important points which you have to remember for class B power amplifier is, the first point is collector current flows for only 180 degrees of AC input cycle. Okay, so collector current flows for only 180 degrees of AC input cycle, that is conduction angle is 180 degrees only. Okay, so conduction angle is 180 degrees only. So Q point in the case of class B power amplifier is located approximately near cutoff region on load line. Okay, so it is located near the cutoff region on the load line. Okay, so this is same in the case of both AC and DC cycles. Okay, so since the conduction angle is 180 degrees only, so output is half sinusoidal. Okay, since it is near to cutoff region, so only negative half cycle exists and positive half cycle is clipped off. Okay, so because the conduction angle is 180 degrees. In the case of class A, conduction angle is 360 degrees and hence the output is complete sinusoidal wave. Okay, but here it is half sinusoidal. Okay, so the fourth important point which you have to remember is very important point: quiescent power dissipation. Quiescent power dissipation or power drain, we'll call that as power drain. That means draining of power or absorption of power is almost zero. In the case of class B power amplifier. That is, in the case of if you are not applied with input, so input is not applied, no current flows in the circuit and hence no power dissipation occurs in the circuit. When input is not applied, no power dissipation occurs in the circuit. Okay, so this is the advantage of class B power amplifier. Okay, so class B power amplifier also uses transformer. Class B power amplifier also uses transformer only. Right, so sixth point which you have to remember is maximum efficiency. So maximum efficiency of class B power amplifier is 78.5%. So maximum efficiency of class B power amplifier is 78.5%. and if you want to find the efficiency, the formula is given by efficiency is equal to pi by 4 into 1 minus V min divided by VCC into 100%. Okay, so this is the formula which you are going to, so if you are given with V min and VCC, the power supply, and you can find the efficiency formula like this from this formula, efficiency from this formula. So but the maximum efficiency is 78.5, so it is again obtained by pi by 4 into 100% will gives you 78.5% only. Okay, so the next important point is there is this is transformer coupled class B power amplifier. So there is another configuration of class B which is called as class B push-pull amplifier. Class B push-pull amplifier or complementary symmetry class B power amplifier. So both the names represent the same thing, class B power amplifier, class B push-pull amplifier or complementary symmetry class B power amplifier. Okay, so this is the second kind of class B power amplifier which we have. So for this also the efficiency, maximum efficiency is 78.5% only, and efficiency is calculated using this formula only, and 180 degrees only. For the 180 degrees only it is having the output, that is output is half sinusoidal, and Q point is nearly to the cutoff region of the load line. So all the points remain same. So in this, transformer is going to be replaced by combination of both NPN and PNP transistors. Okay, so in the case of this, the transformer is replaced by NPN and PNP transistors used in common collector configuration. So these NPN and PNP transistors are used in common collector configurations in the case of complementary symmetry class B power amplifier. Since we are using both NPN and PNP which are complement to each other, that is why this amplifier is called as complementary symmetry class B power amplifier. Okay, so that is why we are giving this name to it. Okay, the second point which we have to remember is so due to this common collector, so impedance matching can be done, right? Impedance matching can be done and frequency response is improved. Frequency response is improved when compared to transformer coupled. Okay, so impedance matching can be done and frequency response can be improved. So the main disadvantage, okay, so the main disadvantage of this class B power amplifier is, first of all, it requires two supply voltages. Why? Because we are using two different types of transistors. For NPN we require plus VCC, and for PNP we require minus VCC. Okay, so two supply voltages are required. Second, very important and asked many times in the previous exams, so crossover distortion occurs. Crossover distortion occurs in the case of complementary symmetry power amplifier or class B push-pull power amplifier. So in the case of complementary symmetry or class B push-pull amplifier only, crossover distortion occurs. Okay, so these are the important points which you have to remember. So maximum efficiency is very important. Okay, so every point discussed here is very important, and keep that in mind. Right, in the next video we will discuss about the remaining two types of power amplifiers. Okay.